I'm saying sorry for the sake of us. Yeah, it wasn't my everything to even nothing, and it's taken me a lot to say. Now that he's gone, my heart is.
So we have to plot the graph of these values against each other. So in this question, we are asked to plot the value of the voltages here against their corresponding currents. So the first thing for us to do is to choose an appropriate scale for this graph. So that is the most important thing that you need to do. Now I'm going to look at the voltage column here. We are going to plot that on this vertical axis. So how do we go about that? Now you can see the range of values from 0.40 to 0.65. Now it means that the least value here is 0.40 and the highest value here is 0.65. Now we have to go and look at this vertical axis here and check if we can accommodate all of these values here starting from the origin. Otherwise, if we cannot accommodate all the values starting from origin, then we may start our graph, the vertical axis, from any of the values given there from this value here, or we drop it down a bit. Okay, let's look at this. If I decide to choose 0.1 cm or 2 cm to 0.10 volts on the vertical axis, surely I'm going to get, starting the graph from origin, 0.0, 0.01, 0.1 rather, 0.2, 0.3, 0.4, 0.5, 0.6 and 0.7. So you can see that these values here can accommodate all of that. So we can start these values here from the origin. So I'm going to name all of that, then I will put my scale on this. So my scale is going to be 2 cm to represent 0.10 volts. So I'm going to have this 0.0. Here I'm going to have 0.10. Here I have 0.20. I'm going to do all of that for all of this. So now these are my values on the vertical axis: 0.0, 0.10, 0.20, 0.30, 0.40, 0.50, 0.60, 0.70. So the scale on this axis is going to be 2 cm, because the length between this and this is 2 cm. This and this is 2 cm also. This and this is 2 cm, just like that until we get to this point. So here the highest value is 0.65. Now I have been able to push this up to 0.70. So all of these values there and on this column here will be accommodated on this part here. So let's go over to the horizontal axis, the y-axis. So on the y-axis, I'm still going to look at all of these values. So I have 0.18 as the least, then I have 0.40 as the highest. So I'm going to check if I can get a value that we can accommodate it. So if I take 0.10 here, I take 0.20, 0.30, 0.40. So it's going to be up to this. But looking at that, you'll find out that it's going to be a very small graph. So I can shift it up to the 0.10, 0.20, 0.30, 0.40, 0.50. So I have been able to stretch and open up the graph by using 4 cm to 0.1 unit. So I'm going to do this. So I'm going to have 0.10 going to have 0.2, sorry, not there, so I'm going to have 0.20. I'm going to have 0.30, just like that, until I fill all others. So these are my scales. So this is going to represent this. I draw this down this way, down this way, down this way, this way, and this is going to represent this. Okay, you can still do this for this point. So these are the points. Then we have to put the values that we are plotting on either side. So I'm going to write here, this is V in volts, and this is going to be I in ampere. Now we have this. Now there's something I want us to take note of that we're going to be using during the course of this practical. Now the space between this and this is 10. Is 10. Yes, when you count this, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have that on this, Now the actual value difference in value is 0.010. So I'm going to divide this by 10. I'm going to divide it by 10, and that is going to give us 0.01. So I'm using this on the vertical axis. We are going to make use of this while trying to read from the graph. So on the horizontal axis, I'm going to have this. So take note of this. On the horizontal axis, the difference between them is also 0. Between 2 values is also 0.10, but the space between them is 20 because it is 4 cm, so it's going to be 20. So I'm going to divide this by 20. So I'm dividing this by 20. I'm going to have this. I'm going to have this 0.10 divided by 20 that is going to give us 0.05. So we have 0.005, rather 0.005. We have 0.005. Now what these two values, this value and this values and this value means is that each division on the vertical axis, each of these lines are divided into 0.01, and for this other side it is divided into 0.005. so each of these lines are 0.005 on the horizontal axis. For the vertical axis, each of the line is 0.01. We are going to make use of them for easy access to taking readings from and drawing out your points on the graph. So this is what I'm going to do. Now let's plot the point. Here I'm going to plot on the vertical excuse me, on the horizontal axis, that is on the current axis. I have 40, then I am plotting 40 against 0.65. Now you see I can directly read 40 from here. It is easy, I can read it from here directly. Now what about 0.65? So what I'm going to do is this. I'm going to do this. The closest point to 0.65 is 60. So I'm going to subtract 0.65 or 60 from 0.65. 0.65 minus 60. That is going to give me 0.65 minus 0.60. 0.65 minus 0.60. So that's going to give me 0.005. Now I'm going to divide the 0.005 by 0.01. So divided by 0.01. So I'm going to have 5. So what that means is that I'm going to move 5 places from 60. So I've just 1, 2, 3, 4, 5. So I have this. So this is my point here. So I'll come back to 40. So if I move it up to 60, so I count 1, 2, 3, 4, 1, 2, 3, 4, and 5. So I'll put a dot there, and I'm going to draw a circle through that. Okay, the circle is a little bit too large. So that is my point. Now you get the importance of that. Now let's go to 0.35. 0.35 against 0.58. So how do I get 0.58 from here? From here, 0.58 is closest to 0.50. So I'm going to do this again. So I'm going to do 0.58 minus 0.50. So that will give me 0.008. So I'm going to divide that by 0.01. So I have 8. So I'm going to move 8 places from 50. So I have 1, 2, 3, 4, 5, 6, 7, 8. Here I'll note that place down. Then I'll go to the other side, 35, 0.35. So to read off 0.35 here, obviously it's going to be the in between 0.03, the midpoint between 0.30 and 0. So it's going to be this. So I'll just trace it up and I count it to 8. 1, 2, 3, 4, 5, 6, 7, and 8. So I put my point here and I'll draw my circle here. So I'll have this. Then again I'll go for 0.50. So this is my 0.50. I can easily get this here for 0.28. So the closest value to 0.28 is 0.20. So I'm going to do this again. 0.28 minus 0.20. So that's going to give me 0.08. So I'm going to divide that by this because I want to take the value on the horizontal level. So I'm going to divide it by 0.005. So that's going to give me 16. So I'm going to move 16 places from 0.005. So this is obviously this is 10, 11, 12, 13, 14, 15, 16. So I can move it upward, or from 50 I can count it from 50. This is 50, so this is 10. This is 10 from 20, from 0.20. So I have to move 6 places. 1, 2, 3, 4, 5, 6. So I'm going to draw my point, my circle here. Okay, the circle is a little bit too big. So I have that. So I'm going to fill all of other points using this same. So these are my recorded points. Now in WAEC physics practical or alternate to practical, what the examiner looks for is how you plot your points. These points that are given here, they try to look at it on the graph and see if they match. For example, here I have 0.65 and 0.4, so they will look through it if my 0.40 matches with my 0.65. so if they match, they will go to the next one and do also for 0.35 and 0.58, then they will go for 0.28 and 0.50. If these three they match, so they will assume that all others are matched. So the next we have to do is to get the slope of this graph, so we get the slope of the graph by to draw the graph rather, so before we can get the slope of the graph. So we are going to do this. We get the line of best fit. So the line of best fit is going to be on top of, so we look for the best line that fits into all of this. Let's see if we can fit all of them into the line. So we can see that we can fit all of the points into on a straight line on these points. So when you are drawing a graph, so when drawing graphs, you do not always want to start it from the origin. What you have to do is to look for the line of best fit, a line that will fit into all these smaller circles that you have drawn. So if you do that, you get your line of what? Your best fit. So I'm going to do this and draw a line across all of this. Now these are where the points end. I can now come and extrapolate other points by drawing broken lines. Please do not draw close lines. Do not draw close lines. So you see that I have drawn a straight line to this point here where the point ends. Then I am extrapolating all others by using short dash lines. So I'm going to use short dash lines until I get to the intercept. So this is my graph. So you see that from this point I extrapolated all of this is the right way of drawing your graph. Now to get the gradient or the slope, I'm going to draw a large triangle across this. I'm going to draw a large triangle across the line, the straight line. So do this, can draw it across any point that I so wish to. So I'll draw a large triangle across this. From this point, I can draw to this point. Okay. So I'll come to this point also and draw a straight line. across this. So I must ensure that the line touches this other point here. So we can read off this from here. So my slope is going to be this point here, from here to this point. So let's get the slope now. So my slope x, okay, I can work that on this point. My slope x is equal to, now I'm going to read off this point from here. Now this is the important one, of the another importance of this. So I'm just going to count the number of spaces that I have here. 1, 2, 3, 4. It was 4. So I'm going to multiply that by 0.01. So I'm going to have 4 times 0.01. So that is going to give me 0.4. Then I'm going to add it to 0.60 plus 0.60. So that is going to give me 0.64. So you see that the uppermost part there is 0.64, 0.64 minus, so I'm going to read this other point here. So this other point is going to be, so I'll start from 0.1. So I'll just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've moved 9 places, times 0.01. That's going to give me 0.09 plus 0.10. So that will give me 0.19. So I have 0.19 divided by, so on this side I'm going to read off this point, that's 0.40, 0.40 minus, so I'm going to read this one off this place. One, this is just one place above this, so you multiply it by 0.05. So that will give us 0.05, 0.05. So we have this 0.64 minus 0.19 equals 0.45. 0.40 minus 0.05 equals 0.395. So when we divide that, we're going to have 1.1. So it is voltage over current, that is volt ampere, which is the same as ohm. So obviously the unknown resistor that was used was a 1 ohm resistor that was we are supposed to detect. Now we can also look for the vertical intercept here. So what you do, just count from 0.1. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So my intercept is going to be 9 times 0.01 plus 0.190. So my intercept is going to give me, it's going to just be equal to 0.19 volts. That is my intercept. Of course, we will not forget to state the title of the graph. So the title of the graph is going to be this graph of V in volts against I in ampere. So this is the title of the graph, and also the scale that was used. So the scale that was used was 2 cm to 0.01 volt on the vertical axis, and 4 cm to represent 0.01 ampere. So we have the scale here. So this is the graph that we are expected to plot and what they ask us to evaluate. So we have this. So that's all. Thank you for watching. See you some other time in our next videos.